Kip Thorne is not just any physicist. He's a Nobel laureate, one of the world's leading experts on black holes and the mastermind behind the science of Interstellar. A pioneer in gravitational wave research, Thorne worked with Christopher Nolan to ensure the movie's portrayal of extreme time dilation was as accurate as possible. But how did he calculate it? Let's dive into the science. One of the most mind-blowing aspects of Interstellar is the time dilation on Miller's planet. In the movie, 1 hour on the planet equals 7 years for observers in orbit or on Earth. This happens because the planet orbits incredibly close to Gargantua, a massive spinning black hole. At first, Kip Thorne thought it wasn't possible. He told Christopher Nolan that a planet that close would fall into the black hole. But Nolan pushed him to calculate it. And using Einstein's general relativity, Thorne proved it could work, under the right conditions. Thorne's calculations showed that 2 key factors make this extreme time dilation possible: the spin of the black hole and the orbit of the planet. First, Gargantua had to spin at nearly the maximum speed allowed by physics. This spin is described by a parameter between 0 and 1, and Thorne calculated that Gargantua's spin had to be almost perfect, 0.99999. At this speed, Gargantua drags spacetime around with it, allowing stable orbits closer to the event horizon. The second factor was Miller's planet. It needed to orbit just outside the innermost stable circular orbit, or ISCO. This is the closest distance where an object can maintain a stable orbit without spiraling into the black hole. At this exact distance, the planet experiences such intense gravitational forces that time slows dramatically, compared to elsewhere in the universe. Using Einstein's equations and the Kerr metric for spinning black holes, Thorne calculated the gravitational redshift, the factor that stretches time near a massive object. He found that Gargantua's spin and Miller's orbit could produce the exact ratio needed for 1 hour on the planet to equal 7 years elsewhere. Thorne used computational tools like Mathematica to validate these extreme conditions. He found that even slight deviations in the black hole's spin or the planet's distance would break the effect. A slower spin wouldn't allow stable orbits close enough, and a farther orbit would weaken the time dilation. Thorne later documented his calculations in The Science of Interstellar, where he explains the exact physics behind the movie. His work ensured that the film's depiction of time dilation wasn't just plausible, it was rooted in real science. Of course, Interstellar took a few creative liberties. The giant wave on Miller's planet, for example, was exaggerated for dramatic effect. But the time dilation itself? That's pure science. Kip Thorne's work wasn't just about making the movie accurate. It was about inspiring audiences to think about the mysteries of the universe. By blending Hollywood storytelling with cutting-edge physics, Interstellar brought concepts like black holes and time dilation to life for millions of viewers. Kip Thorne's calculations for Interstellar are a testament to the power of science and imagination. By applying Einstein's general relativity to the big screen, he showed us a universe full of possibilities. Want to learn more? Check out his book, The Science of Interstellar, and dive into the real physics behind the fiction. Because, in the words of Kip Thorne, if I can see farther, it's because I've stood on the shoulders of giants. And one of those giants is Einstein himself.